Intel Gaudi AI accelerators are popular for their high-performance fine-tuning and inference. Just look how fast Stable Diffusion inference runs on a single Gaudi 2 HPU. Intel Gaudi 2 and Gaudi 3 accelerators deliver industry-leading price performance with flexible scalability. They're available for on-premise deployment and from leading cloud providers. And there are 4 ways to get started. You can use models from Hugging Face Hub with the optimum for Intel Gaudi AI Accelerator library. See my previous video, which I will link to below. You can use PyTorch models built into the Intel Gaudi AI model references repo. Or if you already have PyTorch code set up to use the CUDA device, you can use the GPU migration toolkit to automatically run your existing code. And finally, you can manually convert existing code. But let's focus on the GPU migration toolkit, which is pre-installed with the Intel Gaudi software. If you've tried this toolkit in the past, you'll be pleased to see that it automates even more now. It can be as simple as setting an environment variable and using your existing code. Let's look at the example I was running at the beginning. You can follow along yourself. I'll leave a link in the description. I already performed the setup steps and downloaded the model. After that, just set this environment variable and run the code. This variable turns on automatic mapping of GPU-related API calls to their Gaudi equivalents, so you don't have to edit your existing Python code. This example is pretty straightforward. It parses arguments to configure Stable Diffusion inference, load the model from a checkpoint, set torch.device to CUDA, which will get mapped to the Gaudi equivalent, send the model to the device, get the prompt and set up the output. It runs mixed precision on the CUDA device, which will also get mapped to the Gaudi equivalent. Then it iterates to generate a number of samples, which get post-processed into images. We do add these 2 lines of code. Mark step indicates the end of an iteration of an inference or training loop. This example will run without mark step, but all the loop iterations will accumulate into a single computational graph, which increases memory usage and prevents parallel execution on the CPU host and Gaudi accelerator, like here where the accelerator is running inference and the CPU is post-processing the tensors into image data and saving them. So be sure to include mark step in your inference and training loops. But that's it for code changes. So set the GPU migration environment variable, and I'll also set this log level variable to show how the API calls get mapped. You can learn more about mapping here. Some calls are simple mappings, some get modified a bit, and some are not supported. And now we just run the command from the example. Here are our calls and how they were mapped. Note that we haven't done anything to optimize this specifically for Gaudi other than that mark step call. There's often more you can do to get the most out of your models on Intel Gaudi AI accelerators. This is a topic for a future video. And we have our results. Again, 1 environment variable, maybe add the mark step line of code, and you can reuse your existing Python code. To learn more about getting started with the Intel Gaudi GPU Migration Toolkit, and to access the example code and documentation pages I mentioned earlier, check out the links in the description below.